The universe is filled with objects so vast, distant, and intricately structured that they stretch the limits of human imagination and language itself. When we speak of beauty in space, we are not referring to beauty in a simple or decorative sense, but to a kind of cosmic elegance shaped by fundamental forces acting over immense spans of time. Nebulae, for example, are among the most visually striking objects ever observed. These enormous clouds of gas and dust glow with rich colors, not because they are painted, but because atoms respond to energy in precise and predictable ways. Hydrogen emits deep reds, oxygen glows in soft blues and greens, and sulfur adds golden hues, turning regions of star formation into vast, luminous canvases suspended in the darkness of space. Each color represents physical processes at work, revealing temperature, composition, and motion, transforming raw data into breathtaking natural art. Within these nebulae, stars are born. Gravity slowly pulls gas and dust together until pressure and heat ignite nuclear fusion and a new star begins to shine. This process can take millions of years, yet telescopes allow us to witness different stages at once, scattered across the galaxy like snapshots from different moments in time. Some regions show tightly packed clusters of newborn stars, brilliant and energetic, while others reveal older, more stable stars that have already shaped their surroundings with stellar winds and radiation. The beauty of these scenes lies not only in how they look, but in what they represent. The continuous cycle of creation that ensures the universe is never still, never finished. Beyond nebulae, star clusters offer another expression of cosmic beauty. Globular clusters, containing hundreds of thousands or even millions of stars, form near-perfect spheres held together by gravity. They orbit galaxies like ancient relics, some nearly as old as the universe itself. Their stars are densely packed, creating a shimmering, almost jewel-like appearance that contrasts sharply with the emptiness of surrounding space. Open clusters, by contrast, are looser and younger, their stars still traveling together after forming from the same cloud of gas. These clusters remind us that even stars have shared origins and that beauty in the universe often emerges from connection and structure rather than isolation. Galaxies themselves elevate cosmic beauty to an even grander scale. Spiral galaxies, with their sweeping arms and glowing cores, appear almost deliberately designed, yet their shapes are the natural outcome of rotation, gravity, and dark matter. Each arm is filled with billions of stars, nebulae, and planetary systems, all moving together in a slow, majestic dance around a central core. Elliptical galaxies, smoother and more uniform, radiate a quieter elegance, composed mostly of older stars and shaped by ancient mergers. Irregular galaxies, chaotic and asymmetrical, show that beauty does not require order, only complexity and history. No two galaxies are exactly alike, and each one is a record of cosmic events stretching back billions of years. What makes these objects especially powerful is the role of time. When we observe distant galaxies, we are not seeing them as they are now, but as they were when the light first began its journey toward Earth. Some of that light has traveled for billions of years, crossing expanding space to reach our telescopes. In this sense, the beauty of the universe is also a beauty of the past, a visual archive of cosmic evolution. Every image is a blend of space and time, allowing us to look backward and reconstruct how the universe has changed, grown, and reorganized itself. Even the apparent emptiness between these objects contributes to their beauty. The vast, dark spaces separating stars and galaxies create contrast, emphasizing scale and isolation. This darkness is not truly empty, but filled with faint radiation, drifting particles, and invisible structures shaped by gravity. Against this backdrop, luminous objects appear even more striking, like islands of light in an endless cosmic ocean. The balance between light and darkness gives the universe its dramatic character, reminding us that beauty often arises from contrast rather than abundance. Perhaps most remarkable is that none of this beauty exists for observation alone. Stars do not shine to be admired, and galaxies do not form to inspire awe. Their beauty is a byproduct of physical laws operating consistently across the cosmos. Gravity shapes structure, nuclear fusion powers stars, and electromagnetic forces produce light and color. Yet, when these forces interact on enormous scales, the result is something that feels almost intentional, as though the universe is expressing itself through form and motion. In recognizing the beauty of these cosmic objects, we also recognize our place among them. Every atom in our bodies was forged in stars that lived and died long before Earth existed. The same processes that light up nebulae and sculpt galaxies also made life possible. To look at the most beautiful objects in the universe is not just to admire distant scenery, but to witness the deep connection between humanity and the cosmos. The beauty we see is not separate from us. It is the visual expression of the same universe that gave rise to our existence, unfolding across space and time in endlessly fascinating ways. While nebulae, star clusters, and galaxies often dominate discussions of cosmic beauty, the universe also contains objects whose elegance is more subtle, revealed through motion, precision, and extreme conditions. Planets, for instance, display a wide range of visual and physical diversity that rivals anything found elsewhere in space. Gas giants like Jupiter and Saturn are wrapped in swirling bands of clouds, powerful storms, and immense magnetic fields that shape their surroundings. Saturn's rings, composed of countless icy fragments, form a structure so thin and wide that it seems almost unreal, yet it remains stable through a delicate balance of gravity and motion. These planetary systems show how beauty can emerge from balance, where constant movement produces long-lasting harmony. On a smaller scale, exoplanets orbiting distant stars add another layer of wonder. Though many cannot be seen directly, their existence is inferred through precise measurements of light and motion. Some are scorched worlds locked in tight orbits, while others may be covered in global oceans or thick atmospheres glowing under alien suns. The idea that such diverse worlds exist in enormous numbers reshapes our understanding of beauty, shifting it from what we can see to what we can imagine. Each newly discovered planet expands the range of possible cosmic landscapes, suggesting that beauty in the universe is far more common than once believed. At the opposite extreme are the universe's most intense and enigmatic objects. Neutron stars and black holes are not visually colorful in the traditional sense, yet they possess a profound, almost unsettling beauty rooted in their physics. Neutron stars pack more mass than the Sun into a sphere only a few kilometers wide, spinning rapidly and emitting beams of radiation that sweep across space like cosmic lighthouses. Black holes, defined by regions from which light cannot escape, warp space and time so dramatically that they reshape their surroundings, pulling in gas that heats up and glows before disappearing. The beauty of these objects lies in their extremes, where familiar laws of physics are pushed to their limits and reveal deeper truths about reality. Cosmic events also contribute to the universe's beauty through their scale and impact. Supernova explosions mark the deaths of massive stars, releasing energy so intense that a single event can briefly outshine an entire galaxy. These explosions scatter heavy elements into space, seeding future generations of stars and planets. The glowing remnants expand outward in intricate patterns, forming structures that can persist for tens of thousands of years. In this way, destruction becomes a source of creation, and beauty emerges from transformation rather than permanence. Taken together, these objects and events reveal that cosmic beauty is not confined to any single form. It appears in symmetry and chaos, in light and darkness, in creation and collapse. The universe expresses itself through an endless variety of structures and processes, each shaped by the same fundamental laws, yet producing dramatically different outcomes. To explore the most beautiful objects in the universe is to recognize that beauty is woven into the fabric of reality itself, present wherever matter, energy, space, and time interact.